you ready for the news?
In quadratics today, there are many different equations that may be dealt with, such as general form, vertex, or standard form, even factored form, and even doing it on a graph. Now to Riley.
Thanks, guys. All right, so general form looks like this. Y equals ax squared plus bx plus c. The y represents the output, the a represents the behavior, positive or negative, and the c represents the y-intercept. Vertex form looks like this. Y equals a x times h squared plus k. The y again represents the output, the a represents the behavior, and the x represents the input, while the h represents the axis of symmetry, and the k is the min or max of the parabola.
Thanks, Riley. Now on to our vocab section of the program. The vertex. The vertex is the peak in the curve of a parabola.
The max and min is the highest or lowest point found in the parabola.
The end behavior is a polynomial function is the behavior of the graph as it approaches positive or negative infinity.
The axis of symmetry. The axis of symmetry of a parabola is a vertical line that divides the parabola into two congruent halves.
Roots, zeros, and x-intercepts. These are all terms used to describe where the function crosses the x-axis.
The y-intercept. The one point on the graph where the function crosses the y-axis.
Domain. The domain is a set of all possible input values which produce a valid output from a particular function. The range is a set of all possible output values which result from the particular function.
To find the roots of an equation, you must convert it from general to factored form. First, you must find two numbers to multiply to give you a and c, but add to give you b. Now back to Riley.
Thanks, guys. All right, so an example of general formula would be 2x squared plus 7x plus 3. A times c is 2 times 3, and that equals 6, and the b is 7. So we want to find two numbers that multiply together to make 6, but add up to 7. And 6 and 1 will do that. So we want to rewrite the middle with those two numbers. So it becomes 2x squared plus 6x plus x plus 3. Now I want to factor the first two and the last two terms separately. The first two terms, 2x squared plus 6x, factor into 2x bracket x plus 3 bracket. The last two terms, x plus 3, don't actually change in this case. So you get 2x bracket x plus 3 bracket plus x plus 3. X plus 3 is common in both terms. So we can now rewrite it like this. 2x plus 1 equals x plus 3. Sorry, it has some technical difficulties. Okay, say you're given a point and the vertex, and you had to find the equation. When given the point and the vertex, you generally start out with vertex form. Y equals a x minus h squared plus k. Say we had the point negative 1, 1, and the vertex negative 2, negative 2. We would rewrite the equation like y, a x minus 2 squared plus negative 2. Which would then become y equals a x plus 2 squared minus 2, because the two negatives would cancel out, and the negative 2 would overrule the positive. Because we know that negative 1, 1 are points on the graph, we can substitute them in. And the negative 1 goes in for x, and the positive 1 goes in for y. 1 equals a negative 1 plus 2 squared minus 2. This just leaves us with a. All you need to do to solve for a is you go 1, a 1 squared minus 2. You can then add the 2 to each side of the equation. So it will become 2 plus 1 equals a negative 1 plus 2 squared minus 2 plus 2. This becomes 3 equals a negative 1 plus 2 squared. You can then mathematically do that further. So you get 3 equals a times 1 squared, so 3 equals a. You can then substitute the a into the equation. Y equals 3x plus 2 squared minus 2. Solving and factoring, ax squared plus bx plus c equals y. One way to factor this formula would be regrouping. Say you had an example of 6x squared minus 9x minus 4x plus 6. First we group the two variables together, and then the last two variables together. You would then take a common multiple of each. You can take a multiple of 3 out of the first set and a multiple of 2 from the second set, so it would now look like this. 3x, bracket 2x minus 3, bracket minus 2, bracket 2x minus 3, bracket. You then regroup the two coefficients together to get the answer of 3x minus 2 and 2x minus 3. Sum and product are another example. An example of this would be x squared plus 9x plus 18. First, you need to find two numbers with a product of 18 and a sum of 9. Only 3 and 6 would work for this. So you would replace the 9x with 3x plus 6x and factor by regrouping. X squared plus 3x plus 6x plus 18 becomes x bracket x plus 3 and 6 bracket x plus 3, which then becomes x plus 6 and x plus 3. Decomposition is another way you can again factor the general formula. An example of this would be 2x squared plus 5x minus 12. First you would multiply the 2x and the 12 to get negative 24. Now you need to find a number that multiplies to negative 24 but adds to 5. The numbers that can do this are negative 3 and 8. You then replace the 5x with the negative 3 and the 8x to get 2x squared minus 3x plus 8x minus 12. You should group the first two terms and the last two terms together. Now you start looking for common multiples to take out of each. You can take an x out of the first group, and you can take a common multiple of 4 out of the second group, giving you x, 2x minus 3, and 4, 2x minus 3. Once you group the coefficients together, you get the answer 2x minus 3 and x plus 4. When dealing with difference of squares, an example of this would be x plus 7y and x minus 7y. To factor these, you would use the FOIL law and multiply it out, which gets you x squared minus 7xy plus 7xy minus 49y squared. The two middle terms cancel each other out, leaving you with x squared minus 49y squared, which is the answer. Quadratic formula. Quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac, and all this is divided by 2a. Quadratic formula is used to solve functions that cannot be solved with any other formula as easily. An example, x squared plus 20x plus 15. A will become the coefficient in front of the x squared, b will become the coefficient in front of the x, and c will become the constant. So if we substitute everything from our equation into the quadratic formula, we get something like this. Opposite of 20 plus or minus the square root of 20 squared minus 4 times 1 times 15 divided by 2 times 1. This then becomes negative 20 plus or minus the square root of 340 divided by 2, which can further be simplified into negative 20 plus or minus 2 square root 85 divided by 2, which leaves us with the answer of negative 10 plus or minus 85. Next, we're a man in the field with a real-life example, but first is our commercial break.
I got triangle blue, triangle blue, and I'm trying to find got me a coast. The adjacent lane, now I'm feeling close. Rearranging for the correct equation and solving this triangle. I got the triangle blues, and life's looking bleak. No 90-degree angles, must be oblique. Gotta use sine law, man, it's a fine law. I caught in a tangle, need to find the interior angle. Comparing the ratios using sine angle, A over A equals angle B over B. Got the triangle blues. Those triangle blues. The law of cosine is helpful to find the angle triangles per side. When you know the two others, then you can solve with your brothers. With the equation c squared equals a squared plus b squared minus 2ab cosine of MC. That's the triangle blues, everybody.
Thanks, Riley. I'm here in the field with my man, Brant Wilson, professional basketball player. He's going to use this football today to demonstrate to us what a parabola looks like. Wow, thanks, Brant. Back to you guys in the studio.
Good night, Old High School.